So laws of indices, more to do with just manipulating algebra, really, like we were doing last week. So brackets, factorization, simplifying, and we can use the laws of indices to simplify, and we'll see how that works. And then the main thrust of today is to be looking at solving equations. So I can get you started on that, and you can try some questions for yourself. So let's start off by just looking at these laws of indices. You might want to have these laws of indices on a separate piece of paper ready to put at the front of your notes to refer to, because we're referring to these all the time. Eventually you'll get to know them, but so it's worth possibly having them separate. Even if you don't make them separate in your notes now, you might decide you want to put them on another piece of paper somewhere, summarized or something at the beginning of your notes. Okay, so 6 laws of indices I want to look at. The first one says that x to the power a multiplied by x to the power b is x to the power a plus b. So there is the first law of indices. For example, 2 raised to the power 3 multiplied by 2 raised to the power 4, so the one we're looking at on the previous screen, would be 2 to the power 7. If you look at this law only works if the base is the same, and you can see that in the example. It only works if the base number, which is 2, is the same in both of these. So 2 to the power 3 means 2 times 2 times 2. And 2 to the power 4 means another times 2, 4 times. So I think you can see that we've actually got 7 2's multiplied together. So it's fairly obvious that we just add the powers. And so the law is, whatever the power is, and as we'll see, the power can be a fraction as well as a whole number. If you've got the base the same, x in this case, so x could be any number, but if it's x there and there, it means it's the same both cases, then you can add the powers. First law of indices. For a similar reason, the second law of indices says x to the power a, so this is the second law of indices, divided by x to the power b equals x to the power a minus b. So that's the second law of indices. So again, by example, 2 to the 5 over 2 to the 3. This one, 2 to the 5 would be 5. 2 multiplied by itself 5 times. 2 multiplied by itself 3 times. I think you can see now we cancel. 2's into 2 goes once, 2's into 2 goes once, and so on. I can cancel 3 of the 2's at the top with the 3 2's at the bottom and replace them with 1's. And so I end up with just 2 2's, so in fact that would be 2 squared. So I've subtracted the powers. 5 minus 3 is 2. Second law of indices. And just by looking at an example, you can see how they work. The other 6 rules that we're going to write down now are all derived from this. So they all can be shown to come exactly from this sort of argument. But they tend to be the ones that are the most useful to us. So we use these, but they're fairly straightforward. But from these, we can get some more useful ones. Here's one. Oh no. That is one, but let's write another one first. X to the a raised to the power b is x to the a times b. You just multiply them together. For example, 3 cubed squared would be, you can probably see it from this, it's 3 times 3 times 3, which is 3 cubed, but times by itself again, so it's times 3 times 3 times 3. So we've got actually 6 3's multiplied together, 3 to the power 6. So we actually just multiply the power, 3 times 2 is 6. So if I've got one power raised to another power, which is effectively what this is saying, so I've got 3 raised to 1 power cubed, then I'm raising that to another power, 2, I actually just multiply the powers together. 3 2's are 6. Fourth one is the one I just wrote down, 1 over x to the a is x to the minus a, and this is probably one of the more important ones. So negative power means the inverse. Inverse 1 over, if you like, 1 over something. So if I've got x to the minus a, it means 1 over x to the a, the inverse of it. If you look at an example, and you use the second law of indices, what would you end up with? What does the second law of indices tell me to do, Alfie? Yeah, so 3 take away 5. Right, gives us 2 to the minus 2. But if we think about what they actually mean, this means 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2. So again, we cancel 1 with one of these, 1, and so on. So we replace 3 of the 2's on the top with 1, the other 2's on the bottom with 1, because they cancel into each other. So I'm left with 1 over, because 1 times 1 times 1 is 1 at the top, over 2 squared. So we see that 1 over 2 squared is the same as 2 to the minus 2. In other words, the negative power here means 1 over. The negative power means 1 over. The negative power means the inverse. And that seems to be one that is always tripping people up. So I'm emphasizing it now for the future. Um, 1 over x to the power 5 can be written as x to the minus 5, because the minus power means 1 over, okay? If I put it in the colour, it might emphasize it. 1 over x to the 5 equals x to the minus 5. Minus means 1 over, okay? 4 over x cubed. What would that be? No? 4, say that again. 4. What did you say? No? Remember, 1 over, the divide by something is the same as multiplied by 1 over. We talked about this. times 1 over x cubed. So that's the way to think of it, Tom. Now how can I rewrite it as? Right, because 1 over means a minus power. Okay? Now, I'm emphasizing this because, as some of you know who have been doing some maths with me, and maybe you all know, when it comes to doing calculus, to be able to differentiate or integrate things like this, it needs to be written in the power form like this and not like that. And so you need to be able to use this law of indices to convert it from being written like this to looking like that, and then you can do other things with it. Okay? So that's an important law of indices. Inverse, a negative power means the inverse. You can see it there. Okay? It will trip you up at some point, I'm sure, but if I keep banging away at it. That leaves number 5. And this is this one. The nth root of x to the n is x to the n over m. For example, the cube root of x squared can be written as x to the 2 over 3. So the root goes underneath and the power of x goes on top. You might remember that, those of you who've done this with me, the root under the ground, so that's the way I remember it, okay? Roots, the root sign goes underneath. Yes, m. So another example, not so obvious this one. The square root of x, although it's not stated, if x is on its own, it's to the power 1, but we just never bother to put the 1 in there. And if it's a square root, there should be a 2 there to mean the square root, but again, we never bother to put it in. So we put the 3 in for the cube root, but no power there at all means a square root. So as soon as we see that, we realise that that can be written as x to the 1 over 2, in other words, x to the half. So there's a couple of examples of, again, how you can use the law of indices to be able to do other things to it, like differentiate it or integrate it when we look at calculus. So this is another important rule of indices, to convert something like this, the cube root of x squared, into something we can then integrate or differentiate. We'd write it as x to the 2 over 3. Quite tortuous logic to show you how this works, but I'd like to have a go at it, okay, because I think you deserve the effort. If we think of, trying to think about in terms of the laws of indices we know already, of this problem. The square root of x multiplied by the square root of x must be what? Which is? You're right, Tom. What's the square root of x squared? X. They cancel each other out, don't they? They're opposite effects. So the square root of x times the square root of x is just x. Okay? By definition. Because that's what the square root means. And this is the tortuous logic bit. The square root of x is a number which, if I multiply it by itself, gives me that number. So the square root of 9 multiplied by the square root of 9 gives me 9. What's the square root of 9? 3. So 3 times 3 gives 9. The square root of a number is the number which, when you multiply itself, gives 9. So this must be true. The square root of x times the square root of x is x to the 1. Okay? What must this power be from the laws of indices, if I add them together and they're the same, what is it that gives 1? A half. So x to the half multiplied by x to the half gives you x to the half plus a half, which is x to the 1. So in other words, what is this power? It must be a half, because a half plus a half gives you the 1. In the same way, the cube root would be a number which, if you multiplied by itself 3 times, gives the number. So that must be a third, because a third plus a third plus a third gives the 1. So that's where the root bit comes from in this law. And then, of course, it doesn't matter what it is that you're trying to find the square root or the cube root of. Whatever this number is inside just stays the same. So actually, you're just doing, if you think about this, this is this x squared times a third, because we're finding the cube root. And 2 times a third is 2/3. So that's where the 2/3 comes from. Okay? You don't really need to see this as a process, but I just wanted to show you that actually it can be shown that it's true. I'm not just plucking it out of thin air and saying here's a law, but at the end of the day, you've just got to remember them. Okay? Which is why you need to have them on a piece of paper so you can refer to them. I said there were 6, there's one more. And I'm just going to write this one down and leave you to prove it. I'm using blue pen, right? X to the 0, anything to the power 0 is 1. And I'll leave you to prove that.